कैसे होगी रंग था कोई पेज नंबर 17 पेज नंबर 17 की क्वेश्चन एनालिसिस की कॉपी इंस्टीट्यूट होगी जी ओके से हो रहा जी टॉपिक ना करंट इलेक्ट्रिसिटी सो फर्स्ट क्वेश्चन potential difference between the points A and B is A का B mark के potential difference P रे A का B mark के potential difference पुथुआ है P बना करी P रिबा मखोई इसी की circuit से जैसे लेवल current P रे 2 ampere so 2 ampere current flows through this circuit and since it is a series circuit 2 ampere से तुम whole circuit the whole in whole circuit current will be 2 ampere यार बा because it is a series circuit there is only one part but how to find the value so let's choose a part हम कोई choose तो रजी from A to B let's choose a part from A to B and write the voltage equation so what will be the voltage equation voltage equation का दिखाओ तो बस let's start from A दे हो रेको so B A है then first part to na negative positive terminal the thome since the part first meets the positive terminal the value should be taken as negative -6 and then since the current direction and the path direction and the path direction are same so we will use minus IR minus IR that is I is 2 R is 2 then next the part current I'm not talking about the current I'm talking about the part first meets the negative terminal of the cell then we will use positive na plus 9b sign convention already for class tha tak recall why we choose negative why we choose positive I have already discussed inside the class then next since it is a series circuit or as there is only one part 2 ampere current will flow here also right 2 ampere and since the direction of the current and the part are same then we will use minus IR that is 2 into 1 now the part is complete equals to VB. Let's write this. They are asking to find potential difference BA minus BB. So B is from the law. From the sakro. So 6 plus 4 minus 9 plus 2. It is 10, 12, 12 minus 9 is the potential difference between the points A and B, PA minus BB. So the answer should be why do we get minus plus 1 granny -6 -2 into 2 4 आ रहे हैं +9 ले रहे हैं minus the answer is 3 itself 10 ले रहे हैं 12 ले रहे हैं so 3 volt the answer should be 3 volt if the potential difference is between B and VB minus BA then only we will get -3 -3 phang do ko du kan ta VA minus BB should be 3 but the man is the potential difference between the points A and B have any A ga B ga mark potential difference so the answer should be 3 itself so manatro I'm thinking is called last one I'm thinking is so BA ले रहे BA -6 ले रहे -4 ले रहे then +9 ले रहे -2 ले रहे +6 is umsa krani then +4 good so the answer is 3 volt the answer is 3 volt yeah right so option the -3 have yaure option is chuman 0 chuman 0 potential difference high ravani na ko makoi market difference to be 3 tare adu kana ke market no do high ravani na ko if the sense is B minus A की सेंस हो इतारा का दी -3 चुम दोगा आई आंसर से तुम चुमन के 3 तारा बाउद दो -3 करो को got it so in a meter bridge the balancing point is found to be at 39.5 from A हर जगह से देखिए it's 39.5 centimeter चलेगा we find the balance point when the resistor Y this resistor Y is 12.5 यार वासी की Y की value period 12.5 the value of X is we need to find the value of X for meter bridge meter bridge use the principle of balanced pressure bridge so at balance point or the null point the ratio of this resistors X by Y should be equals to this path length ratio of this path length which is say AJ divided by JC AJ is 39.5 then last one makha dudi masam thanda kya tare 61.5 yaar hoga 69.5 because it is 100 minus L1. We need to find the value of x. X put होगी 39.5 divided by 61.5 into y. Y is the क्या है माना 39.5 divided by 61.5 into 12.5 यानी अब good. अरे कमाई हो चुके हैं. See, check the answer. Answer is check the row. Answer के तभी the values are two apart को. क्या मैं लामना कर रहे तो इतारे approximation sin और यानी approximation sin तभी the direct sin of the क्या है. Say 5 5 25 haro 5 to 10 11 12 5 5 6 62.5 को वर्ग दिस ना 5 divide तो याद हो बको ना 5 ना सीधा divide तो रादी 5 by 14 ना थ्रो so it will be approximately 8 so in exam do not go for actual calculation as I repeatedly advise for inside the class. In exam, if the values are too far apart, then the best way is use the approximation method. Rough calculation में तारो, do not go for actual calculation because it will simply waste your time. Question number 3. A total of 6 into 10 to the power 16 electrons pass through any cross section of a conducting wire per second. The equivalent current is. See, equivalent current or I is nothing but charge divided by time. Total charge divided by time. And they are giving the number of electrons. So using the quantization of charge, Q is nothing but Ne, where N is the number of electrons divided by time. Here they are saying per second, so take time as 1 second. Number to Nagano 6 into 10 to the power 16. E is 1.6 into 10 to the power minus 19 divided by 1. So this much ampere. Answer will be 9.6 into 10 to the power minus 3 ampere, which is 9.6 milliampere. Very simple. Very simple. Next question number 4. In the hydrogen atom, an electron moves in an orbit of radius 0.53 angstrom with a speed of 2.2 into 10 to the power 6 meter per second. Calculate the equivalent current. Say electron for any charge particle, it may be electron, it may be proton, or any charge in a circular orbit moving at a speed of v in a radius of r. Current I equivalent will be nothing but charge divided by time period. The time taken to complete the one complete loop. So charge here, the charge is electron. Since it is electron, it will be E. Time period is nothing but 2 pi r divided by speed, that is v. So let's substitute the values and try to get answered. E 1.6 into 10 to the power minus 19. V is 2.2 into 10 to the power 6 divided by 2 pi r. What is the value of r? 0.5 angstrom. Angstrom is nothing but 10 to the power minus 10 meter. So let's think how should we take the value of pi, whether we should take it 3.14 or 22 by 7. I think it will be better to take 22 by 7 because 22 have a mathematical in numerator we get a number 2.2, so it will be easier to take 22 by 7. So 2 into 22 by 7. Good. Then 22, 22 it is 0.1. Yeah, so 2 into 0.5, it is 1. Just remove it. 7 mathak zakro. So the answer will be 7 to 1.6. 6 7 is 42. It is 111. Here we have 0.1. 0.1 with 10 to the power kalani minus 19. Minus 19. This minus 1 plus 6 and then plus 10. Maka isi ko. But the 11.2 into 10 to the power kya la rahe se 16. It is 20. 16 I will minus 4 minus 4 ampere. So it is nothing but 1.12 into 10 to the power minus 3 ampere, which is 1.12 milliampere. Okay. Good. Very simple. Next question number 5. The current through a wire depends on time as. They are giving current as a function of time. It is a variable current. I note there is the current at t equals to 0. That is initial current is 10 ampere. And the value alpha is 4 ampere per second. Let's first write this in a very simple form. Let's substitute the values. I note is 10. Alpha is 4. So I is nothing but 10 plus 40. Right? To find charge, we can use a relation Since instantaneous current I is dq by dt, then to find charge dq, then use dq equals to I dt. There is a small charge. Since charge is a scalar quantity, to find the overall total charge, we can just do integration. So I dt. Take proper limit. Say they are saying in 10 seconds. In 10 seconds means starting from 0 to 10 seconds. So substitute the values of, let's substitute and integrate. So 10 plus 40 dt 0 to 10. What do we get? 10t plus 4t square by 2. So let's take the limit. It is 0 to 10. It is 0 to 10. So the answer will be 10. 10 minus 0 plus 2. 10 square minus 0 square. So what do you get? 100 plus 200, which is 300 coulomb. Very simple, very simple. Just a simple integration and you will get answer. So question number 6 to 8. There is an instruction. There are two statements. Read the statements and answer it. Choose the correct option. Option number A, if both are correct and statement 2 is the correct explanation of statement 1. For statement option number B, both are correct, but statement 2 is not the correct explanation of statement 1. Option number C, statement 1 is true, but statement 2 is false. Option number D, statement 1 is false, but statement 2 is true. So let's choose the options. Question number 6. IV graph is given. There is an IV graph. See, usually when we discuss inside the class, we discuss the graph for V versus I. V is in, usually V is in y-axis and I on the x-axis. But here, he reversed the axis, okay? He changed the axis, so don't get confused. In BI graph, what we discussed in the class was that in BI graph, slope. By Ohm's law, V equals to IR. So I is nothing but V by R. In this graph, V by R is nothing but slope. Slope means tan theta. So in short, oh sorry, it should be R. R should be equals to V by I. Slope is nothing but tan theta. So resistance, the slope in the VI graph, slope of the VI graph gives the resistance of the conductor, right? So as theta increases, resistance will definitely increase. Here they are talking about the temperature. If nothing is mentioned, then consider that all the geometrical values, that is radius, length, area, cross-section area, they are all same. Since it is for the same conductor, we can also assume that the resistivity, the material is same. Material will be differently, obviously because temperature is different. So let's write the expression resistance of a conductor equals to rho L by A. As length and area is going to be assumed as constant, then resistance depends only on this resistivity, that is the material property and the temperature. Resistivity depends on the types of the material and temperature, obviously, and pressure. For conductor, temperature increases. As the temperature increases, conductivity increases, and obviously resistance will also increase. So what they are saying is that temperature graph, they are giving this temperature. Let's modify this IV graph in this form. So definitely T1 will be here. It is closer to the I, so it is the curve, and T2. We are going to check which temperature is higher. So in this graph, it is quite obvious that theta 2 is greater than theta 1. So automatically R2 is greater than R1. Since length and area are assumed to be constant and they are of same material, resistivity or resistance will depend solely on temperature. So for a conductor, as temperature increases, resistance increases. So as R2 is greater than R1, T2 will be greater than T1. Okay, T2 will be greater than T1. So it is correct. They are writing here something like this. T1 is greater than T2. Just ignore it. Okay, just check this statement. Next, resistance of a conductor increases with rising temperature. What is the reason for this? First statement is correct. Second statement is also correct. Whether the second statement can explain the first statement, obviously. As the slope is more, resistance is more for the second line. As resistance is more for the second graph, temperature will be definitely greater in the second wire, because as temperature rises, resistance also increases for conductor. So both statements are correct, and the second statement is the correct explanation of the first statement. Question number 7. A resistance wire is broken into 4 pieces and all are connected in parallel. A wire is broken into 4 equal pieces. Since the wires are broken into 4 equal pieces, resistance of each piece will be R by 4. Let's assume that this is the wire and the total resistance is R. If we cut this into 4 equal pieces, R of each piece will be R by 4. Because resistance is equals to rho L by A. For same material and same temperature, resistivity is constant. Area, if by simply cutting the wire, area will not change. Obviously, length will become 1 by 4. So as length become 1 by 4, resistance will also become R by 4. So each piece resistance is R by 4. The net resistance, and then these pieces are connected in parallel. These are connected in parallel. So R by 4, R by 4, R by 4, and R by 4. All are connected in parallel. For parallel combination, R net will be R of each resistor divided by number of resistors. There is R by 4 divided by 4, which is R by 16. Okay, good. So the first statement is correct. In the parallel, net resistance is less than the smallest value of the individual resistance. Obviously, it is also correct. But the thing is, whether this second statement can explain the first statement. The decrease in resistance does not simply give the value, cannot give the value of 1 by 16. Obviously, if the statement says that the resistance is less than the initial resistance, then this could possibly explain the first statement. But second statement says that the first statement says that the value should be exactly 1 by 16. This 1 by 16 number cannot be deduced by simply just simply saying that the net resistance will be less. Okay, both are individually correct, but the second statement cannot explain the first statement. So the option number B. Question number 8. Potential difference across the terminals of a battery is always less than EMF of the battery. Potential difference across the terminals of a battery is always less than the EMF of the battery. It is not true. It is true potential difference across the terminals of the cell. There is a terminal potential and this is the EMF, internal resistance. Terminal potential will be less than EMF, less than or equals to EMF in discharging case. Discharging, that is when we are using this cell. But V becomes greater than E, that is EMF, while charging the battery. In the charging case, while charging, the terminal voltage becomes greater than E. So always is wrong. Okay, it is less than EMF of the cell while it is discharging, while the cell is used. But during the charging process, the terminal voltage is becomes greater than the external becomes greater. While charging a cell, the terminal potential becomes greater than the EMF of the cell. Good. So first statement is wrong, second statement is correct. So the option is D. Question number 9. Estimate the average drift speed of conduction electrons. They are asking to find the drift speed. Cross-section area they are given. It is given, and the current is also given. Number density is also given. So to find drift velocity, we can use the relation I equals to current I equals to what happens to my pencil? Okay, that was I equals to NEA VD. So we can use this because other values are known. To find VD equals to I by NEA. Current is 1.5 ampere. Number density is 8.5 into 10 to the power 28. E is 1.6 into 10 to the power minus 19. And then area, cross-section area is 10 to the power minus 7. Okay. Good. Let's do one thing. Let's combine the powers first. 8.5 into 1.6 into 10 to the power, it is minus 28. It will become minus 28 and then plus 19 and plus 7. So it becomes 26 minus 28. So it is minus 2. It is minus 2. So power becomes minus 2. Power becomes minus 2. Power becomes minus 2. So it is 10 to the power minus 2. minus 2. See, in all the answers, they are written in mm per second. So let's make this minus 3. If we want to make this minus 3, then we can write 15 here. Okay, 15 here instead of 1.5. So what do we get then? The denominator becomes 5.5 into, so 1.6. Let's do one thing. It is 1.2.2, 1.1, 0.1, 3.3. Then we do like this. 6 sub n. Let us assume that this 1.5 is 1.6 is 1.5. Can we do it? I think it will be better if we just find the values. Let's find the exact value. 85 into 1.16. So let's say 90 minus 5. Okay, into 16. So it is 9, 654, 144, 0, then IT, right? I think it's correct. So 1360. 1360. Then digit any character. So it is 13.60. So the answer is it is 13.60. If we divide this 2.2 target, the answer comes out to be, I think it will be greater than 1, but less than 2. It will be greater than 1, but less than 2. I think the answer should be 1.5. Approximately. I think it's correct. So 54, let's cross check for one last time. 14 layer. Minus 36 layer, 3 layer, 136, 13.60. So obviously it is greater than 1, but less than 2. So this answer. Okay. Meter per second. So it will be 1.1 mm per second. As I said before, do not go for actual calculation in exam. It will simply waste your time. Since there is answer in front of you, try to choose the correct option. Probable option. Probable option doesn't khal over. Now let's see question number 10. A charged particle is having a drift velocity in an electric field. The electron mobility will be. Okay, Ray. We know that the drift mobility is equals to drift velocity divided by electric, right? Drift velocity divided by electric field. Drift velocity, they are giving this as 7.5 into 10 to the power minus 4. Electric field, 3 into 10 to the power minus 9. Don't worry about the units. Okay, then. So 10 to the power minus 9, when it goes to the numerator, it becomes 10 to the power 5. 3, it is 2.5. Okay, 2.5 into 10 to the power 5. 2.5 into 10 to the power 5. So option is B. Option is B. Next, question number 11. Just you must know this relation. You must know the order of this conductivity. Say they are giving 4 elements. One is nichrome, copper, germanium, and silver. We know that silver is the best conducting element. So silver, conductivity of silver is the highest. First silver, because I'm going to order in terms of conductivity, silver, and then this copper, and then copper. Then I think the first two is very simple and very clear. Some may confuse between nichrome and the germanium. See, nichrome is an alloy, a conducting alloy, and then germanium is a semiconductor. So compared to nichrome and semiconductor, nichrome will definitely have a better conductivity. Clear? Good. So the answer is, the order is silver, copper, nichrome, and germanium. Option number C. Option number C. Good. Next, nichrome has a resistance 73.5 ohm, 75.3 ohm at 30 degrees Celsius. The resistance of a nichrome becomes 85.8 ohm when current passes through it. If average temperature coefficient of the resistance of nichrome is this, the temperature of the nichrome now, initially, the resistance was 30 degrees Celsius, and at this temperature, the resistance was 75.6. As current flows, definitely the wire will become heated. As the temperature increases, its resistance also increases. Definitely. So they are asking to find a temperature at this point, at the point when its resistance becomes 85.8. We can use a relation RD at the given temperature equals to R naught, that is at the reference temperature, 1 plus alpha delta T, where alpha is the temperature coefficient of resistivity. So RD is given as 85.8 equals to R naught. Let's take this as R naught, 75.3, 1 plus alpha. They are giving this as 1. Let's do one thing. Just write alpha, okay? Alpha delta T. Then expand this. 85.8 equals to 75.3 plus 75.3 alpha delta T. When we subtract, what do we get? 10.5 equals to 75.3 alpha delta T. So implies alpha delta T will be equals to 10.5 divided by 75.3, right? Then above the delta T, 10.5 divided by 75.3 into its alpha value is 1.7 into 10 to the power minus 4, right? So say delta T is nothing but T minus T naught and this value. So T will be equal to T naught plus this value. What will be the approximate value of this? See, it is 100, 700, it is 750. T naught is 30. Okay. So 750, 850, 900. Let's see how can we solve this. How can we handle this? 10.5 into 10 to the power 4. Let's do one thing. Let's put all these zeros here. So that it will be 105,123. Okay. 75.1.7. 75.3 into 1.7. So if we take 1.7 as 2, I'm assuming this as 2, then what will be this value? 150.6, right? 150.6. So 150.6 divided by, dividing the 10,500, it's not 10,000, 105,000. How much will we get? Will it be more than, say, 105, 150? If it is 9, 9545, 919, 113, 113, it is more than this. 900 could not be the answer. Let's do the simplification. Combine approximation low by. How can we do the take the approximation? 5. So let's do one thing. 105 divided by, let's divide by 2. I think it will be better. And we have 0, 1, 0 hum nahi doga. 2 kya aa raha hai? 51, right? 52.5. 52.5. Let's say 525 into 100 divided by 75. 75 ने सीधे divide करा दी क्या था नहीं? 75, 749. Okay. 7535 ले रहा 49, 52, 525. Direct divide हो गया रही रेसिना. 2 लोग उतार गई. So 75 dividing 525. 35. So इधर कोई जा. Kaya ano ko yung divide to rin 7 ako. 7 535 lai re. 7 49 52 chumi mani ne. Adu di 5 tari re jam. 500. So 500 is a 2 log even. The 500 dekar chaurani 600 hai 700 swaji lai do male. I think it should be somewhere around 700. I think it should be somewhere around 700. I will do the calculation. Now let's do a direct calculation. Let's do direct calculation. I'm using a calculator online. So I'm using the calculator online, which you can do inside the class, inside the exam. I was get the direct over again. So the answer is 10.5 divided by 75.3 and divided by 1.7. So it comes out to be 820 tare, 120 plus it comes out to be 850. 850. It comes out to be 850. So calculation becomes a bit difficult. It may be because of these steps I use. So yare no calculation for them in exam, do the proper calculation and you will get this answer. Okay, the rule is very simple. Rule is very simple. Okay, now how is it? Otherwise combine calculation do something now how is it? A battery of EMF 5 volt and negligible internal resistance is connected across the diagonally opposite corner of a cubical network consisting of 12 resistors of network, each of resistance 1 ohm. Inside the class, I have written this formula. Kasi mamu khanna ningsango. Across any diagonal, across any diagonal, across any diagonal of a cube or cuboid, whose face have the same resistance, whose face has the same resistance. So if R is the resistance of each face, each side of the each edge size, each edge size. Adu itagadi R net across any diagonal. She can have it is nothing but R 5R by 6. It is 5R by 6. In this question, they give R as 1. So the answer is resistance of each R net across any diagonal is 5 by 6 ohm. Now this whole circuit I can convert like this. Nangi R net high row, R net is nothing but 5 by 6 ohm. And then this 5 volt, and this will be the current I. To find this current I, we can use B divided by R net. B is 5, R net is 5 by 6. So the answer comes out to be 6 ampere. The answer comes out to be, okay. They are asking, this is the current, total current. Now they want to find the current. They are asking to find the current along one edge of the cube, one edge, one side. Since due to symmetry, current on each edge will be this figure, the current S1 in this figure, it will be, so let's use this small I. It will be I by 3 because this I will be equally distributed in this 3 edge. So I by 3, that is 6 by 3, which is 2 ampere, Here it is 2 ampere. Good. Next question number 14. Question number 14. 4 arms of the Wheatstone bridge have the following resistance AB. Everything is given in the diagram. Let's focus on the diagram. From this diagram, it is clear that it is not balanced. Let us use this P, Q, R, and S. P by Q is 60 by 100, which is 3 by 5. And R by S is 12 by 60. Then this is the 1 by 5 to R by. It is 1 by 5. Since P by Q is not equal to R by S, it is not a valence Wheatstone bridge. So further in the question, they says that calculate the value of additional resistance connected across CD. Across the CD, how much resistance you must connect in parallel. Calculate the value of additional resistance connected across CD. So they are asking to find the resistance connected in parallel to balance the bridge. Okay. Galvanometer में calculate the value of additional resistance connected across CD. Obviously, so let's find the resistance. So another resistance is connected in parallel here. Let's say this value S1. So to make this balance, this balance, so P by Q should be equals to R by net of S and S1, S and S1. So it is something but R divided by S, S1 divided by S plus S1. Have the two resistors in parallel, R1, R2. Magi net kamay tagi, R net is nothing but R1, R2 divided by R1 plus R2. Right then. Good. So P की value क्या है? What is the value of P? It is 60. Q is 100. R is 12. The S is 60 divided by 60 plus S. Yeah, good. Let's solve this. 6, 12 tarani. The 100 sikal na karo. 2, it is 3. So what we get is 60 plus 3S divided by 60 plus S is equals to 1. And the 3S equals to 60 plus S. The 2S lie and S comes out to be 30 ohm. S comes out to be 30 ohm. Yeah, S comes out to be 30. Calculation is do the calculation by yourself. Take your time. Take your time. Speed will automatically increase. Don't worry. Next question number 15. Two wires A and B of the same material. Same material. So resistivity will be same. Having radii in the ratio of 1:2, carry currents in the ratio 4:1. The ratio of the drift speed of the electrons in A and B is. We know drift velocity. We know that I will be equals to NEA VD. That is, VD is NEA divided by I. Right. To find the ratio of the drift velocities, dV BD1 divided by BD2. 1 means A. Since the wires are same and they mention nothing about the temperature, we will assume that temperature is also same. If the material and temperature is same, if the material is same, then obviously number density will be same. Okay, number density will be same. Let's forget about the temperature. It has nothing to do with the temperature. Since the material is same, number density of the electron will be same. So n will be same. So in finding the ratio, let us not use n. E n, E are all same. So let us not use this. What we get is it should be A1 divided by I1 whole divided by A2 divided by I2. So it is A1 by A2 into I2 by I1. Yeah, so A1 by A2 area has A1 by A2 is nothing but R1 by R2 का whole square because area is pi R square into I2 by I1. R1 by R2 is in the ratio 1:2 and current, don't confuse cause do not write 4:1. You must write 1:4 because it is 1 I2 minus I2 by I1, not I1 by I2. So it comes out to be 1 by 4 is to 1 by into 1 by 4, which is 1 by 16. So 1:16. 1:16 is the answer. Question number 16. Question number 16. When the current I is flowing through a conductor, the drift velocity is B. If 2I current flows through the same material, so N will be same, but having double the area of cross section, then the drift velocity will be. I think it is the same type of question. They are asking the same type of question. Drift velocity, as we have just written, go I by NE Electron, I by NE. Initially, say let's use the symbol V2 by V1. V2 is a new value, V1 is the initial value. In both the case, in the second case, the current is 2I. So it will become Sumaina Hanam the easy. Let's write in a better form. I2 by I1 because NE will be same. Into, since it is inversely proportional to the area, so it will be R1 by R2 whole square. Because area is nothing but pi R square. We have just solved it. I2 by I1, I2 is nothing but 2I and I1 is I into R1, that is initial value, R2 is in second value, new value. Having double the area. My mistake. Soy recall. Since the drift velocity is inversely proportional to area and they are giving in terms of area. Area A1 by A2. So I2 by I1 kya tani? I2 is 2I, I1 is I. A1 divided by A2. They say that the new area is double the initial value. So there will be twice A. Okay. And initial is A. So 2 kaya I, finally what we get is 1:1. Oh, 1. We get 1. So implies V2 will be equal to V1. As they say that V1 is B, so V2 will also be B. Very simple. Question number 17. Let's talk about question number 17. The electrical resistance of a certain wire of iron is R. If its length and radius are both double, R is nothing but rho L by A. Rho has nothing to do with the geometry of the wire. It depends on the material, type of the material, and the temperature. If nothing is mentioned about the temperature, then assume that temperature is constant. Okay. So rho L by A. So for the same material, certain wire, as material does not change, and the temperature is going to be assumed constant. Rho to constant in lower ka. Taking rho as a constant, what we get is R depends on L by A. Okay. Mana kaya ba? Length and the radius of both the wires are double. And we can further write like this. Since area is pi R square, So you can write like this, R depend, resistance depends on L by R square. By question, length has become double. Length double वगैरह है रे. Length has become twice L. And R has also become double, twice R. Then resistance will become L तो क्या तार है हो जाए twice L. अब मैं दूंगा twice R का whole square. अभी क्या तार नहीं. So I think it's better to use like this. R ds equals to rho L ds by hangi L ds by A square and it's my logical. Yarava A ds rho L by A. Rho L ds is nothing but twice L. Area the pi R square ni new R is twice R whole square. So what we get is rho layer L by R square. Give it a side. The other value is 2 divided by 4. Pi jo sitham auro. So it is 1 by 2, 1 by 2. So 1 by 2 of rho L divided by pi R square. Rho L pi R square is the initial value. So it is R by 2. Resistance becomes half. Resistance has become half. But resistivity rho will not change. No change. Resistance has become half. Resistance has become half, but resistivity will not change. So what will be the correct option? What will be the correct option? Resistance will be double, which is correct. Resistance will be half, and the specific resistance will remain unchanged. Option number 3 is the correct option. So make us next question number 18. Question number 18. Masses of 3 wires of copper, all are of copper material, are in the ratio 1 is to 3 is to 5, and their lengths are in the ratio of 5 to 3 is to 1. Ratio of their electrical resistance. To find the resistance, we have nothing to do with the mass. But from this mass, what we can find is we can find the ratio of the areas, area cross-section areas. Let's use it. What is given is length of the ratio, mass, okay, mass of the wires. M1 is to M2 is to M3. It is 1 is to 3 is to 5, right? And the ratio of the lengths, L1 is to L2 is to L3. They are all 5 is to 3 is to 1. What we can use is, let's assume that length 1 is 5x, L2 is 3x, L3 is x. We can write like this, right? M1 can be taken as M, 1M, 1M, okay? M2 as 3M, M3 as 5M. So instead of x, I think it is also better to write L. Let L1 be 5L, then other length will be 3L and L, okay? Smile. After knowing all these values, we know that using mass is nothing but volume into density, right? Rho is density, density. Then M1 is to M2 is to M3. It is again volume is area into length, cross section area into length into density. This is density, not resistivity. Okay, good. M1 is to M2 is to M3. It is equals to A1 L1 is to A2 L2 is to A3 L3, right? So it is nothing but M1 is nothing but M is 2, M2 is 3M is 2. Why I am writing all this? Why I am using this? Why I am using this? Let us not write like this. Let's directly find the areas. Let's directly find the areas in terms of density. I think it will be better. Using mass as volume into density. Volume is area into cross-section length into density. Here rho is density, not the resistivity. Then what will be your A1? A1 area will be, say, let's say A. A will be equals to M times L the rho, right? So it will be A1 will be equals to M1 divided by L1. Rho is going to be constant, so just write rho. Do not write 1. M1 yung mahuta, M rho, L1 yung mahuta. It is 5L, okay? So this is your A1. And A2, write like this, M2 divided by L2 rho. M2 is 3M, L2 is 3L rho. And A3 is M3 divided by L3 rho. M3 is 5M divided by it is 3L rho, right? We get all the values, all the necessary required values. Then we can find the ratios. Then resistance ratio R1, R2, R3. It will be resistance is rho L by A, right? Let us not write a rho here because resistivity and this density will get confused. So by just ignoring the resistivity, what we can write is A by A. A1 by A1 in ratio, common term common term will be cancelled out. So we can write like this. A1 the kya है A1 is nothing but M divided by 5L rho is to A2 की mahota L1 further L1 lam रखी दौनी and L1 is 5L ज्ञान ताई को increase है is to nasai R2 दी क्या नो what is R2 mark is A2 by L2 A2 is nothing but 3M divided by 3L rho yarava aduga sida nangi L2 is 3L ratio is 2 nasai A3 it is 5M divided by 3L rho aduga nangi length it is L yarava cancel all the common terms. So what we get is 1 by 25 is to 3 3 का 3 रमाइज है कोको A2 is 3L by 3 M to the 3M ले रहे okay इसी का पुका में से यार का है so it is 1 by 3 is to 5 by 3 right multiply every all the terms by 3 3 ने multiply तो क्या तारे से 3 ना थे 25 into 3 ने multiply तो राधी सीधा 3 तारानी सीधा नंगी 25 तारानी सीधा ना 125 ताता हुआ so the answer comes out to be 3 is to 25 is to Chumibo. Kadai don't swear is book, kadai don't swear is let's recheck it. Let's recheck the answer call. M1 L1 ले रहे M1 M1S क्या नो M ले रहे L1 से में ले रहे M2 3M 3L रो ले रहे अदे इधर नंगी सीधा M3S 5M divided by 3 L3 दाइना 3 increase के दो भाई नो L3 दाइना 3 increase के दो भाई नो C3 से मुकत्तलो C3 से मुकत्तलो so it should be only 5 यारबा 5 ಅದು ಈ ತರ ಗದ್ದಿ M3 ले रहे हैं 3M by 3L रो ಅದು ಮಾಗಿ L2 ಮಗ 3L लाया 5 by mass ले रहे हैं L रो ಅದು ಸಿದಂಗಿ L ಮಗ ले रहे हैं L ಮಗ ले रहे हैं ಅದೇ ಮತ್ ಲಾಸ್ಟ್ ಆಫ್ 5 ತಂಗ್ ले हो रहे हैं हां बे टर्म द कमाए नो सी लाक्सली से लेट्स सी M ले रहे हैं अब दी 5L ले रहे हैं लेंग अमगो हफ्से लगांदा 5L ಅದು ಸಿದಸು ನಂಗಿ 3L ಮಗ हफ्से ले 3 3 का करे 1 by 25 ले हो रहे हैं 1 by 3 ले हो रहे हैं मतलब 5 ले हो रहे हैं पता है दोनों सोई रिजवो को let's uh try to get the answer am the yang is mass of the three wires are in the ratio 1 is to 3 is to 5 M1 M ले रहे हैं M2 3M ले रहे हैं M3 5M ले रहे हैं L1 L2 L3 the 5 3 1 ले रहे हैं L1 is 5L L2 से में ले रहे हैं mass is nothing but volume into density and the area पुतो के है तारे mass by नंगे L into rho ले रहे हैं the M divided by M1 M1 the M ले रहे हैं तो हमारी L1 the 5L ले रहे हैं अदे नंगे 3M divided by 3L ले रहे हैं तो नंगे 5M divided by L ले रहे हैं अदे माइज the area resistance of the row O resistance have a kanda kai doga daba it is ngi so hydrogen I made a mistake here. I made a mistake here. Let's do one thing. I'm going to remove all the common terms in ratio. Ratio the low common term log is so resistance has the L by A. We don't have L1 by A1 is 2, L2 by A2 equal is to L3 by A3. So ratio the low in kakak row. The L1 the simply nangi 5 tang thamo adu area dana kaya thamdo no 5 tang thamo. Yarava just write 5. L2 dana kya no thamdo just write 3. Aduga A2 dana kya no thamdo 3 by 3 the 1 यार 1 दंग थमो then last नगी L द क्या नो L3 द just write a 1 A3 the 5. So this should be done. This should be the value. So it is 5 it is 1 is to 3 is to 5, 1 by 5. It is 1 is to 3 is to 1 by 5. Multiply every term by 5, then you get 5 is to 15 is to 1. 5 is to 15 is to 1. Sumdribo sizomo. Sumdribo to isbo. Kai shwarigi. Bit ka laite hai. Bit ka laite hai. Kai dono. L1 yamota. Square bang ka sida. Square bang ka. So kamay ito ba siya? So L1 yamota. Instead of L1, I write 5. Right? Instead of A1, just write 1 by 5. It should be 1 by 5. It should be 1 by 5. It should be 1 by 5. Exam do already 2 in it. So it is 25 is to 3 is to 5. 1 is to 5. 3 is to 1 by 5. Then low in multiply 30, it is nothing but 125 is to 15 is to 1. Pay love. My mistake, my mistake. A lot of calculation mistake. Yeah, right, Fare. So question number 18, it is done. Next question number 19. Next question number 19. What happens? Next question number 19. Next question number 19. Two resistance R1 and R2 are made of different materials. Put a star mark here. Temperature coefficient of the materials of R1 is alpha and that of R2 is minus beta. Resistance of the series combination of R1 R2 will not change with temperature. Then first let's find it change in the resistance. Change of resistance. Voila. Let's try to find the change in resistance as with temperature. So that is delta R2. Nazi. So let's try to find delta R. Delta R is nothing but nangi R naught alpha delta T. There is the temperature coefficient for 1. So there is a delta R1. R naught ki mahota instead of R naught, let's write R1. R1 alpha delta T, right? For next resistance, for the new second resistor, delta R2 will be R2 times alpha. There is nangi thermal coefficient duni. For this thermal coefficient, the value is minus beta, right? So minus R2 beta delta T. Now they said that the resistors are in the series combination. Series combination with 34 series combination, this is R1, R2. Overall change in resistance. Yeah, we have discussed this in error also. It is nothing but delta R1 plus delta R2. So overall change in resistance will be delta R1 plus delta R2. So delta R1 is nothing but R1 alpha delta T plus minus R2 beta delta T, right? My question is says that the change will not, this change in the resistance, it is independent, the resistance is independent of temperature. The resistance of the series combination will not change with temperature because it means when connected in series, the net resistance has nothing to do with the temperature. There will be no change in the resistance even though the temperature changes. So that is, or we can write like this, since R net does not change with temperature, does not change with temperature. So delta R net must be 0. There should not be any change with a change in temperature. So implies R1 alpha delta T minus R2 beta delta T. Delta T equals to 0. So R1 alpha equals to R2 beta. So R1 by R2 will be beta by alpha. So the answer will be beta by alpha. Question number 20. In the network shown below, the ring has zero resistance. Ring has zero resistance. I think it's simply a wire. This is just a copper wire. Equivalent resistance between point A and B is. Use naming of the points, naming of the junction. Since there is no resistance potential drop across these wires, so what we can say is if This point is named as, if this is point B, we can use this point as B, this also B, and this as center. Yeah, then 3R, 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 these three resistors are connected between C and B in parallel. So let's redraw the circuit. So it is V, it is C, and then C ga A ga marakta. There is a resistor between C and A, right? Good. So it is 3R, 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 and it is R. 3R, 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 three resistors in parallel. Then their net will be B, C. There is 3R by 3, which is R. And this is R. And now these two resistors are in series. So your R net will be definitely 2R. R net will be definitely 2R. Okay. Question number 20. Come we question. R net will be definitely 2R. Question number 21. The equivalent resistance between point A and B is. Similarly, just like we did the previous question, let's name these junctions. If this point is B, then we can name this point as B also. This point also as B. This point should be another junction because there is a resistor. There's a resistor between this point and other point. Na A ga C ga mark to R layer, B ga C ga mark to R layer, C ga B ga mark to R layer. So use another name. Now let's redraw this circuit. Since these are and these are between B and C. So these two are in parallel. So C is the thumb, B is the thumb. These are and these are in parallel. The next resistance is nagi A layer, C layer, and amana A ga B ga. So here is A. There is two more resistors gone. Yeah, one is across A and C, one is across A and B. One is across A and B. Good. So these are and these are, they are in parallel. Parallel oitadi, their value should be R by 2. And then sidanagi Aram direct, this is your C, this is your A, this is your B. And another resistor R in parallel. R and R plus 2, R and R by 2. If connected in series, so the answer is 3R by 2. This is R. So the answer will be, since these are in parallel, ko adu tadi R net kamai any 3R by 2 into R divided by 3R by 2 plus R. So it will be, say, 3R divided by 5. 3R divided by 5. 4. So the answer is 4. Question number 22. Question number 25 out right, Ramji. Let's solve up to question number 25 for this session. The remaining 25 question, I will provide the answer in the written form. Written form the empiric again. A wire of resistance 12 ohm per meter is bent. Sit. Sexual causing. Be careful. 12 ohms per meter. They are not saying that this 12 ohm is for the whole resistor. It is for per meter. Is bent to form a complete circle of radius. Then first, let's try to find the length, total length of the wire. Total length of the wire will be the circumference of this circle. There is 2 pi into R is 10 means 0.1. Okay, 0.1 meter. This is the total length. Then resistance of the whole wire. Whole wire to get resistance for every meter it is 12 ohm. So for this much meter, the answer should be 12 into 2 pi into 0.1. This much ohm. It is 2.4 pi ohm. In answer, pi is also involved, so don't substitute the value of pi here. Now this whole resistance is divided into two sections, upper section and the lower sections. If we connect a battery here, then these two sections can be set as a parallel combination. Okay, there's A, Siranangi, B layer. So it is a parallel combination. It's a parallel combination. Since the lengths are same in the upper part and the lower part, the resistance of each section will be R by 2, where R is the resistance of whole section. So this is nothing but, let us use this as symbol R. It will be R by 2 and this is R by 2. R by 2, R by 2, two resistors in parallel. then net resistance will be R by 4. Your R is 2.4 pi ohm divided by 4, so it is 0.6 pi ohm. 0.6 pi ohm. Question number 23. It's a very important theory discussed in the class. 5 identical cells, each of EMF E and internal resistance R, send the same amount of current through an external resistor R, whether the cells are connected in parallel or in series. Whether you connect the external circuit in the series combination or parallel combination of the resistors, then the ratio R by R will be 1. Then the R by R will be 1. Okay, good. Know this question. Just I had this question. Question 24. Last question for question 25 over see. So last again. The potential difference between the terminals of a cell in an open circuit. Open circuit means the battery is not connected to any circuit. So this potential difference is simply the EMF of the cell. Okay. EMF is, let us use the symbol. E is nothing but 2.2 volt. Okay. EMF to remember is. When a resistor of 5 ohm is connected across the terminal of a cell, now a resistor is connected. Now a resistor is connected 5 ohm connected across this cell. Then the potential difference between the terminals of the cell, terminal potential difference comes out to be 1.8 volt. This terminal potential is nothing but it is a potential difference received by the external circuit, right? The internal resistance of the cell is. So how to find this? Let's do one thing. Let's first find the current. After finding the current, then we can find any other values. We can find the value of R. We can find, I think, R only. R only is unknown, so we can find these values. The whole circuit say let's first find I. I will be nothing but I is nothing but use this circuit. So initially, what we can do is, as in open circuit, in closed circuit, after connecting the 5 ohm resistor, B is nothing but B equals to E minus IR. Obviously, we can use this also, but as R is unknown and I is also unknown, there's another equation. Also, there is another equation, V equals to IR. Right. From here, we can find the value of I. It is B by R. B terminal potential is 1.8. R it is 5. So the answer is 0.36 ampere. Okay. Current is 0.6. Using this in one, B equals to E minus IR. Terminal potential is 1.8. EMF is 2.2. I is 0.36. And this R. So 0.36 R should be equals to 2.2 minus 1.8, which is 0.4. And then R is 0.4 divided by 0.36. It is nothing but the 40 by 36 for 10 for 9. So 10 by 9 ohm. 10 by 9. Calculation part, I will advise you to do by yourself. Take your time. Use a method you have been practicing. If you want to learn any new, say, ways to solve problems, it's the time now. Practice it now. But when the exam is near or inside the exam, do not use any new method, even though that method is better method. Okay. So whatever method you are practicing, you are using now, the same method you should use inside the exam hall to solve any problems, especially the calculation part. The figure below shows current in a part of electric circuit, the current is. Since there is no battery involved in between, what we have written inside the class also is I in whatever current entering this whole circuit is equals to I out. The current which is going out of the circuit. So kana say in origin, what are the currents? 2 ampere, 2 ampere. Incident orido. N is 2 plus 2. And see the 1, 1.3 and I, they are the outgoing currents. So 1 plus 1.3 plus I. So 4, so from the ladi kya minus 2.3 equals to I. So I will be equals to 1.7 ampere. I will be equals to 1.7 ampere. Okay, that's it. So we have discussed 25 questions out of the 50 The remaining 50 questions, what I will do is I will give you in the PDF format, not a video solution. Any questions, if you have any confusion, then you can ask inside the class or after the class, or you can send a screenshot of the question in my WhatsApp number. Okay. Okay, Are, see you next time. Bye bye.